Hello students, today we shall study tricks for melting and boiling point for P block elements. At first we know what is melting point. The temperature where solid converts into liquid is known as melting point. And what is boiling point? The temperature where liquid converts into its vapor state is known as boiling point. Let's see this. This is boron family, this is carbon family, this is nitrogen family, this is oxygen family, this is halogen family, and these are noble gases. Now let's see here, boiling point and melting point decreases along the groove. From here to here, boiling point and melting point decreases for these two family, boron family and carbon family. Now, for nitrogen, oxygen, halogen and noble gases, boiling point and melting point increases along the axis. From here to here, boiling point and melting point increases for nitrogen, oxygen, halogen and noble gases, and boiling point and melting point decreases for boron and carbon family. Here we take boron, aluminium, gallium, indium, thallium. Now
the group.
Why this is so? For boron, the size of the atom is small. For boron, the size of the atom is small, so intermolecular forces of attraction is more. Intermolecular forces of attraction is more, hence boiling point is also high. For this reason, the boiling point is high in boron. And for this thallium, what happens? The size of the atom is big, intermolecular forces of attraction is less here, and hence boiling point is less. So as a result, what happened? The boiling point of boron is high, then aluminium, then gallium, then indium, then thallium. This is the boiling point order. Boron greater than aluminium, greater than gallium, greater than indium, greater than thallium. See here, this is boron, aluminium, gallium, indium, thallium. This is the boiling point order. Now next see carbon. What happened for carbon family? We know for boron and carbon family, boiling point and melting point decreases along the axis. So for carbon family, carbon greater than silicon, greater than germanium, greater than tin, greater than lead decreases. So carbon, the boiling point of carbon is high. Now next is fluorine. Here we take fluorine. For fluorine or halogen family, what happened? Boiling point and melting point increases along the axis, so the boiling point of fluorine is less, then chlorine, then bromine, then iodine, then arsenine. Next we see this noble gases. Helium less than neon, less than argon, less than krypton, less than xenon, less than radon. These all are trend. Now let's see nitrogen family. What happened for nitrogen family? Here we take nitrogen, phosphorus, arsenic, antimony and bismuth. Now we have to write the boiling point order. But here you should remember that this fourth position shifts from here to here and this fifth position shifts from here to here. And the order will be nitrogen, phosphorus, arsenic, bismuth, antimony. Now this is the order: nitrogen less than phosphorus, less than arsenic, less than bismuth, less than antimony. This is the boiling point order for nitrogen family. Let's see the oxygen family. Now for oxygen family also it will be same. oxygen, sulfur, selenium, tellurium, polonium. What happened? This tellurium shifts from here to here and this polonium shifts from here to here. So we get oxygen less than sulfur, less than selenium, less than polonium, less than tellurium. This is the boiling point order. Now let's see, these all are the boiling point order. Now let's see the melting order of melting point. At first we take here for this helium and for these noble gases and halogen there is no exception. So we get the melting point order: helium less than neon, less than argon, less than krypton, less than xenon, less than radon. And for halogen also we get fluorine less than chlorine, less than bromine, less than iodine, less than arsenic. This is the melting point order. For these two groups we get no exception, but for the rest four groups we see an exception. For this we should remember 3545. 3545. We should remember this trend, and for if we remember this trend we can easily do this. Now here we take boron family: boron, aluminium, gallium, indium and thallium. Here this is 3 position and this is 3 position and this is 5th position. Now what happened? These 3 positions shifts from here to here and this 5th position came here, and we get the melting point order. What we get the melting point order? Boron less than aluminium, less than thallium, less than boron greater than aluminium, greater than thallium, greater than indium, greater than gallium. This is the melting point order. 3 position shifts from here and 5th position shifts here. Now next we see carbon family. Here we have to remember 4th and 5th position. This is 4th position and this is 5th position. This atom shifts from here to here and it shifts here, and as a result we get carbon greater than silicon, greater than germanium, greater than lead, greater than tin. This is the melting point order. This is the melting point order. Now here we take nitrogen, phosphorus, arsenic, antimony and bismuth. Here also we have to remember 3, 5. So these 3 positions shifts from here to here and this 5th position shifts from here to here, and as a result we get this nitrogen less than phosphorus, less than bismuth, less than antimony, less than arsenic. This is the melting point order. Now let's see oxygen family: oxygen, sulfur, selenium, tellurium and polonium. How we write? Here we have to remember 4th, 5. This shifts from here to here and this shifts from here to here, and as a result we get oxygen less than sulfur, less than selenium, less than polonium, less than tellurium. This is the melting point order. So make such paper cutting and write the melting point and boiling point order and paste this in an exercise book or in the wall which you see every day.